So actually, I was asked to talk about the cultural environments that stimulate creativity, and this isn't so much from my own research as it is really theoretical, historical. So I'm going to really talk about the environment in Renaissance Florence and how great geniuses like Leonardo da Vinci and Michelangelo were nurtured. And of course, obviously, Leonardo is a great universal genius. Some of his accomplishments are summarized there. So what are the forces that create such great creativity? And a big question, and one that I think about a lot, is the role of nature versus nurture. Nature is something we're born with. Is it inherited? Does it run in families? Can we enhance it? Can we suppress it? Almost certainly we can do both. We can enhance and we can suppress. And then nurture, how much is creativity created by environmental factors, and what factors enhance creativity? So there have been some great cradles of creativity: 5th and 4th century Athens, Renaissance Florence, which I'll primarily be talking about, Elizabethan England, 18th century America, one could even say late 19th century America, 19th century Paris are just a few of the great cradles of creativity. And this is really limiting us to European type creativity. So let's start with Leonardo. He was the illegitimate son of a merchant class father and an uneducated peasant girl. No known creative talents in either parent. His mother raised him during his first 5 years. When his father was unable to sire a child, he had Leonardo move in with him. And what was interesting was that this little boy manifested very great talent in both drawing and music, which was just striking. So there was some kind of inherent creative nature, but it didn't seem to be inherited because there was nothing in either parent, at least. So his father took him and some of his drawings to Andrea del Verrocchio, who was at that time perhaps the foremost Florentine painter and sculptor. And when Verrocchio saw what the boy was able to do, he was hugely impressed, invited him to become an apprentice in his studio. So now Leonardo was in a nurturing environment. The interesting thing is that Leonardo was so gifted that he soon surpassed his master, the greatest artist in Florence at the time. These are some of Verrocchio's accomplishments. Very great sculptor. That equestrian statue is almost unbelievably difficult to produce. The David is kind of wimpy, but so be it. And his paintings were somewhat stylized compared to what Leonardo was going to be achieving. So here's what happened. Verrocchio was painting a baptism of Christ, which you can see there above Verrocchio's name. He asked Leonardo to do this little bit here. And that's shown in larger right over here. And it may be evident to you immediately that that's easily the best part of the painting. So Leonardo painted that angel, and as I've said, that was the best part of the picture. And Verrocchio was so upset that he never painted again because he was chagrined to be outdone by a mere child. So here's another very famous Leonardo production, The Last Supper. Now, it doesn't look like that anymore. It's really worn away. But the challenge that Leonardo faced was to do a novel painting on what was a very standard theme at the time, and very commonly in Renaissance, on down through 18th and even 19th century art, it was very common to have a topic like Madonna and Child, and to figure out what would be the new thing that you could do with that topic. And so Leonardo decided to paint the moment when Christ said somebody's going to betray him. Now, with that, the most important faces were those of Jesus and Judas. And while working on the painting, Leonardo would stop and think. And finally, the prior of the monastery complained to Ludovico Sforza, who was his patron, Leonardo's patron, about how he was lazy. Leonardo was lazy. And Leonardo had this response. I'm going to read it. He made it clear that men of genius are sometimes producing most when they seem least to labor, for their minds are then occupied in the shaping of those conceptions to which they afterward give form. He told the Duke that the two heads were yet to be done, that of the Savior, the likeness of which he could not hope to find on earth, and had not yet been able to create in his imagination, in perfection of celestial grace, the other of Judas. He said he wanted to find the features fit to render the appearance of a man so depraved as to betray his benefactor, his Lord, and the Creator of the world. He said he would still search, but as a last resort, he could always use the head of that troublesome and impertinent prior. This made the Duke laugh with all his heart. The prior was utterly confounded and went away to speed the digging in his garden. Leonardo was left in peace. So from that, we have an important message. People who are creative spend a lot of time in kind of free-floating periods of thought. I do a lot of imaging, and this is a state that we often refer to as random episodic silent thought or rest. And during that kind of state, an inspiration may come as the brain spontaneously self-organizes and new associative links are formed. The uncompromising and obsessional perfectionism that seeks to achieve the ideal product. And Leonardo never finished the face of Jesus. He could not make it perfect enough. Leonardo was also a scientist. He had an extraordinary knowledge of anatomy, both human and equine. His drawings are clearly based on anatomical dissections in a time when such activity was not allowed. Big industry in grave digging back then. This gave him the capacity to visualize extremely well in 3 dimensions, an ability that was really relatively uncommon at that time. So here is one of Leonardo's drawings showing how he did tomography, slicing through at regular intervals. So the principle is that you go through a structure, an arm, a leg, a brain, at regular intervals in order to create in your mind the 3-dimensional relationships of the components. And this is now what we use all the time in modern biomedical imaging. The most famous used to be the CAT scan. Now it's the MR scan, which doesn't emphasize tomography, but certainly uses it. So here are some of my images slicing through the brain, which we do all the time, and then we put the pieces back together so that we have something like this. So Leonardo's big competition was Michelangelo, another great universal genius. Michelangelo was a sculptor, a painter, an architect, and I mean, he was really good at all of these things. He was a good poet. He was an engineer. He designed St. Peter's Cathedral. He was an anatomist and a scientist. We don't make them like that anymore, and that's one of our problems. So here's one of his very first statues, an amazing feat in marble, chiseled away, and you get faces like this and faces like this. And I often think about when he did this finger. Imagine hacking away at a piece of marble, getting that one finger sticking out there and not breaking it off. What a feat of bravery it was to do that. And this very young man between ages 22 and 24. It's, in St. Peter's, and this beautiful statue got attacked like now 20 years ago and kind of beat up, but so it's now behind plexiglass and not as easy to see. I can remember when I was a very young person being able to go in there and walk around it, walk around it, walk around it. There are things you can't do anymore because of the world we live in. So here's another set piece, David. And if you just look at Donatello, onto Verrocchio, and onto Michelangelo, you see what a change there was in how the human body was understood and how the character of David was understood and how people's sense of masculinity changed over time. The earlier ones are quite effeminate, whereas Michelangelo's David is this handsome young boy standing there with his ball, trying to plan his attack. So what forces nurtured this inherent but not inherited creativity in both Leonardo and Michelangelo, two of the greatest geniuses of all time? And this was the environment of the Renaissance, but especially Renaissance Florence. What did Renaissance Florence have? It had the gate to paradise. All these people that are listed are Florentines who were very creative. Those golden plates were done by Giotto. There was a competition. Competition was a big deal back then. People tried out to do various projects for the city patrons. And several people did elaborate sketches. What did Giotto do? He walked in, said, "I'm going to draw a perfect circle," and then drew it. And he won the competition. So some of the things in Renaissance Florence, there was freedom, novelty, a sense of being at the edge. They had rejected scholasticism and discovered classical ideals. They had discovered humanism, the glorification of the human form, the human mind in classical art. And you certainly saw that in David. They had intellectual freedom, the spirit of breaking out of old and oppressive boundaries, doing what people had not yet done, doing what people, thinking new thoughts, finding new ways to express, experimenting with new techniques, exploring new ways to perceive man, nature, and religion. It must have been a hugely exciting time. I like to go there in my brain. Then in addition, there was a critical mass of creative people, which is very helpful. Interaction with others and intellectual exchange of ideas is catalytic for the creative process. Art in Florence was created in studios and shops where there are groups of young men, and they were all competing with one another. They were also looking at what others were doing. And then there were the philosophers, the poets, and back then even the politicians. That should get at least a little laugh. Well, that was pretty weak. Let me do it again. Add to that the philosophers, poets, and even the politicians. Good. Astonishingly rich congregation of human beings who created social networks that cross-fertilized one another and from which new ideas could emerge. Then there was the competitive atmosphere that was fair and free. As I've already said, a lot of Renaissance art was commissioned by local guilds or city authorities, and they asked artists to compete for projects. Creativity thrives on individualism and open competition such as this. And the competition also occurred because, as I've said, there were also the set themes, Madonna and Child, Last Supper, David and Goliath. And artists worked within these themes and sought to outdo one another. And then there's economic prosperity. Almost all periods of great creativity involving multiple people have been times of economic prosperity. It provides the accumulation of intellectual resources in which ideas can be stimulated, in which they can bubble and ferment, the collections of earlier art, the libraries, the salons and gardens where people could meet and discuss and argue, provides the financial resources to attract the numerous people who form the critical mass. It provides the funds for raw materials, They weren't cheap in those days. Marble, paint, paper, wood, glass, and gold provided the funds to commission artists and pay them. And as great cities form and remodel themselves architecturally because of economic prosperity, a visual atmosphere is created that is itself inspiring. I often think about the development of Vienna at the end of the 19th century, the development of Paris. Those cities were built on prosperity. What about the role of nurture? The environment into which a person is born makes a difference. And this is a very important point, and one I think about myself often. Had Leonardo been born 200 years earlier or later, we probably would never have had the body of work that he produced. And I think about it myself because I know if I'd been born 100 years ago, I would not have been able to have an education because women weren't given them back then. Or if I had been born in Saudi Arabia, I wouldn't have, so it makes a difference. So Leonardo or Michelangelo, Leonardo would not have had the mentorship of Verrocchio in the studio system. Anatomical dissections would not have been possible. Prosperity would not have been adequate to support him. He would have had a creative nature, but it might never have become manifest had he lacked the nurture of a supportive environment. So, what are the implications of this? This is the last slide, and it's really an important one. We live in an era when art and science are seen as separate pathways in life. Leonardo and Michelangelo saw them as the same thing. And I think we need to think about whether this polarization is detrimental to our educational systems, to the development of our children, and even the health of our economy. I'm a strong believer in the unity of art and science, not the polarity. So thank you very much.
So, two monks are talking to each other, and the one says to the other one, "I've got a big problem. I want to spend as much time as possible during the day praying, but I'm a 2-pack-a-day smoker." And I went to the Monsignor, and I asked him, "Can I smoke while I pray?" And he said, "Absolutely not." And the other monk said, "Wow, that's a big surprise. I went to the Monsignor and asked him, 'Can I pray while I smoke?' And he said, 'Sure.'" That is actually the basis for a thesis I'm going to share with you this evening about genius. And to kind of encapsulate that thesis, I'm going to read you just one very short paragraph from this book, Genius Unmasked, which I wrote a couple of years ago. "Genius, it is a word that invokes mystique. Such thinking is inscrutable, even though its results are recognizable as creativity on a revolutionary scale. Although the product of genius is, by definition, surprising, some of the routes taken were a series of predictable steps. Other courses seem to pop out of nowhere. Sometimes geniuses envisioned their terminus far off in the distance. Other times, their destination was unforeseen. To date, however, no one, not even the autobiographical accounts written by geniuses themselves, has produced satisfying insights into their thinking process. How did radical innovators think? Perhaps their minds, prepared through the providence of genetics, were simply lucked upon by chance. Or perhaps, as it sometimes seemed, their visionary insights were attained through divine intervention. But could there be an entirely different explanation? Could there be a more knowable process underlying genius? And then I go on to say, what I hope to demonstrate in these pages is that genius is achieved through a thinking process that is less mystical than it is systematic. I hope to show that even the greatest of innovative minds has used a cognitive toolbox that can be opened and understood. So that's my thesis for you this evening in extraordinary brief. I'm going to very, very quickly run through some of the components that I am convinced through writing this book Genius has used, some of the tools in that toolbox. And in other books that I've written, I actually teach people how to use those tools. I teach it as a university professor. It's actually currently available as a massively online open course for free on the edX platform that will ran this past summer. 14,000 students participated, and will start running as a self-paced course starting at the end of November. So if you want to learn something about how to kind of up your level of genius, that might be a fun way to do it. Okay, so the first thing to say is there any evidence that genius can be taught? And in fact, the answer to that is absolutely yes. We have this urban legend that genius is somehow innate, and as Nancy has just shared with you, that really turns out to be empirically untrue. So there have been these systematic methods that have been used for 40 years now to try to increase creativity, mostly in grade school children. And consistently, what's been found, and these are just two meta-analyses that summarize some of that evidence, is that people who engage in not a 20-minute lecture or a 1 hour lecture, but a course, a number of weeks of training, can achieve 2 to 3-fold increases in their fluency of generating thoughts and the novelty and originality of those thoughts. And in the small number of studies in which professionals have been trained, it's been shown that when they go back into the workplace, they have better problem solving, they have better attitudes about work, and their performance actually improves. And these results are actually across the board. In other words, one of the things that also is kind of an urban legend and a misperception about genius is that you have to be very, very smart to be very creative. And it actually turns out probably to be a genius, you have to be very smart. But to be very creative, you really don't have to be. So these programs work for people across the IQ range. And they also work for people at a multitude of different ages. So you don't have to be, there's not an age where you say, well, I'm too old to be creative. That just is not the case. So there are 3 conceptual components to the program that I teach. One is recognizing and finding alternatives to our habitual cognitive patterns. The second is learning to use tools that enhance generative ideation, and then aligning all of that with the scientific process, because I teach this in the context of science and the scientific creativity and innovation process. So the absolute essence, the kernel of this, is exactly the joke that I just shared with you. There really were 2 components of that joke, right? The first one was, it's surprising. All jokes are surprising, but they're surprising in a very specific way. Jokes, I actually like to say, are kind of the highest form of creativity and innovation, because they do a very specific thing. What they do is they send you down a particular cognitive path, and you're walking down that path, and then they go, zoom, and they kind of make this sudden right turn, right? There's some relationship between the path that you were on and the path that they suddenly take you down, right? So it's not schizophrenia, it's not completely unrelated, but in fact, it is what we call a frame shift. And frame shifts are, in fact, what I consider to be the absolute essence of radical creativity, and in fact, the tool that was used most beautifully by geniuses. So this is what I call overcoming our habitual cognitive patterns, because what frames are is they are the way in which we interpret new information. So basically, we have a set of assumptions and expectations that we use in interpreting new information and making sense of it. So let me just give you an example of a frame shift. When you go to a restaurant, you have a large number of expectations about what's going to happen, right? I mean, just think about it for 1 second. All the things that you expect to happen when you go to a restaurant. You expect to be served food. You expect that the food is going to be palatable. You expect that it's going to be hot if you order a hot dish, that it's going to be enjoyable, on and on. So anyhow, let's say that you go to a restaurant and you order a nice plate of steaming pasta, and the lovely waitress brings it to you and kind of steps back and says, "Is there anything more I can bring you?" And you say, "Yes, would you mind very much bringing me some Parmesan cheese?" And she smiles and says, "Go to the kitchen and get it yourself." Right? So that's exactly what you were expecting. That's no surprise, right? Actually, this happened to me when I was in New York City. That's why I tell the story. It's not a joke. I wish it were a joke, but it wasn't. In any case, so again, what happened? It was a frame shift. It was not what you were expecting. It didn't meet your expectations and assumptions. It was a sudden right-hand turn. Now, there's a fascinating thing that then happened, right? First of all, you laughed, right? So, goes again to show you what jokes are all about. But what happens to you at that moment, and what happened to me certainly in this New York City restaurant, was I didn't know what to do. I did not know what to do. Okay, so wow. Am I supposed to answer that? Am I supposed to actually walk to the kitchen with her? Am I supposed to figure that there's something very, very wrong with her? How do I interact next? Is she dangerous? I mean, you really don't know what to do. And it's a perfect example of the power of frames. Frames are the grease for society. They are absolutely ubiquitous. At any given moment in time, we have gazillions of them operating. You have all sorts of frames sitting right where you are right now about what I'm going to do, what other people are going to do. If the person sitting next to you were going to grab your sleeve and wipe their nose on it, you'd be, taken aback, right? I mean, you wouldn't know what to do. So they're all of those things, and they're also emotional. You have a visceral reaction when somebody breaks your frame, and they're also contextual. So they're different in different countries, for instance. You have different expectations when you go to a new country in terms of the way that people will interact with each other, for instance. So the bottom line is, however, that in order to be revolutionarily creative, radically creative, to change society, you have to break frames in a fundamental way. And it is very likely the reason that radical innovation is so unacceptable. So typically it takes 10 to 20 years, more likely 20 years, for instance, a scientific innovation to be accepted as mainstream. Most often, and in many of the stories that I wrote about in Genius Unmasked, those geniuses' ideas were rejected across the board before ultimately they were accepted. So another aspect of frames is that they are articulated by metaphors. You can find frames are very, very, very hard to identify because they are the air in the room, right? We breathe them, we need them, they're the grease of society, yet they are so embedded in us, we literally don't realize that they're there. They're so fundamental. So, perfect example, the war on cancer, okay? When we talk about any relationship between man and disease, we talk about it as a war metaphor. We battle, we eradicate, we eliminate, et cetera, et cetera. Every metaphor that we use basically is a war metaphor, the war on cancer. If I was going to say to you, okay, so I have a different metaphor. How about cancer as neighbor? You'd say, that's a little crazy. What does that mean? I'm supposed to invite cancer home and serve them dinner? I mean, what does that mean, cancer as neighbor? Well, I take that from Robert Frost's famous poem, Good Fences Make Good Neighbors. And what did he mean by that? What he basically meant was, you don't have to love your neighbor as long as you can fence them out. Now, it actually turns out that this metaphor has become absolutely central, probably the one most central and important area of research in cancer science today. And that is basically that rather than focusing on the cancer itself, you can focus on the fence around the cancer, which is basically our immune system. And an enormous amount of research now is being done on kind of buffering the immune system so that it can attack the cancer rather than focusing on the cancer itself. And this has actually led to many important epiphanies. Okay, so extremely briefly, what are a few of the tools that help us to identify our frames and overcome them? So one, of course, is observation. That's no surprise. I mean, we all know that in science and art and in writing, whatever it may be, observation is a critical feature of genius. It's a critical feature of creativity. Every single genius that I reviewed in this book, and this is kind of a storybook of about 14 different geniuses from the 19th and 20th centuries, but every one of them was the consummate observer. But here's a great example about observation. Warren and Marshall and the Nobel Prize for their discovery of Helicobacter pylori. How many of you know what H. pylori is? Probably many of you, yeah. So it's now thought to be the cause of about 85% of stomach ulcers. And Warren was a backwoods pathologist in Perth, Australia. He was just a total run-of-the-mill pathologist doing normal clinical pathology in this unknown place. And he noticed, he was a great observer though, he noticed that in these slides that he was looking at of stomach biopsies, there were these funny little anomalies. There were these weird little dots. And he tried everything to make them go away because of course he figured, as anybody would, that there was a problem with his slides, that there was a problem with his stains, there was a problem with his microscope, but it wasn't any of those things. He couldn't make it go away. And in fact, the more he looked at them, the more they were there all over the place and in most of the biopsies. So he hooks up with this guy, Barry Marshall, who's a newly minted resident. And by the way, that's also important because it's usually young people that Nobel Prize work is typically done within a dozen years of academic training. So, the two of them hook up, and Marshall says, well, I think they're bacteria. And Warren says, you're absolutely out of your gourd, because all the textbooks say that bacteria can't grow in the low pH environment of the stomach. Of course they're not bacteria, right? So Marshall is convinced. They try to grow it in an animal model. They can't. They can grow it in a petri dish, maybe, but it's kind of weird. Anyway, bottom line is finally Marshall says, well, I've had enough of this. And he swallows the content of one of these petri dishes and induces in himself an ulcer, has himself endoscoped, proves it, and that was the proof of principle, okay? No joke. And they won the Nobel Prize. So sometimes what you eat is what you get. It's really important. Okay, so analogy is a second one. I'm not going to go through this in any detail. All of you kind of know what analogy is. I'll just give you one of these examples. Jenner famously was the inventor of the first vaccine. It was the smallpox vaccine. Anybody know this story? Really cool story. Yeah, he observed, also a great observer, that when a smallpox epidemic passed through a village or a town, that the milkmaids never got smallpox. Ooh, what was that about? Well, what they did get was they got this very benign disease from their cows called cowpox that looked a little bit like smallpox. It had pustules. So he basically says, wow, I wonder what would happen if I took some of the pus from this pustule and I kind of put it under the skin of people who had never come into contact with smallpox, and maybe that would actually protect them. Maybe being exposed to cowpox protects you. Okay, fine. So he does this experiment on some, this was way before IRBs, some non-consenting individuals, including his 1-year-old son. He really believed it. And when the next smallpox epidemic passed through, guess what? You know what happened, right? None of them got smallpox. All right, but that's an analogy because cowpox is to smallpox, right? So you're taking this analogy of what happens in the one and moving it into the other. One of my favorite tools that is rarely used in science and really should be is reversal. Now, we use reversal only when we're kind of, slapped up against the head by it in something that we call serendipity, which has been called a happy accident. So Alexander Fleming, we call the father of antibiotics, and we might call him the father of serendipity. Do you know what Alexander Fleming proved? He proved not only is eating good for you, but he also proved that going on vacation is good for you. So here's how this story goes. Basically, he was a bacteriologist, and he had these plates of Staphylococcus aureus, which he was studying, and he went on vacation. And when he came back, one of his plates was contaminated with yeast. And so he was about to do the exact same thing that every other bacteriologist had always done through the course of time, which was he was going to throw it out, right? I mean, because it was contaminated, right? Except that, again, he was a phenomenal observer, and he took a really good look at it, and he said, oh my gosh, there's something fascinating going on here. Around the yeast was a green ring, a zone where no bacteria grew. So what had he done? He had basically taken the presence of something, which is what he was studying, Staphylococcus aureus. Now he's focusing on the absence of something, which is this ring where nothing grew. And he suddenly realized, he had this epiphany that this was very, very important because there was something inhibitory going on. He instantly became a mold biologist, a mycologist, and figured out that ultimately it was penicillinase, which makes penicillin. But the point is that reversal can happen purposefully rather than accidentally. So there are two ways that reversal happens purposefully. One is that you do things backwards, right? Rather than, it's kind of like what we do when we pack. Rather than kind of following a line of logic forwards, when we pack, we kind of think, oh, okay, well, this is where we're going. This is how many days we're going. And so these are all the things that I need to back up and have in my suitcase in order to, have a reasonable vacation. The other thing that you can do is you can negate things. So that's like what Alexander Fleming did. And you can even reverse things in the sense of, we always think of science as being kind of exposure outcome. You can switch those two, which is a really strange thing to do, but sometimes it works in a very interesting way. Now, in terms of reversal, I have to share with you my favorite because I'm a public health person. My favorite reversal is medicine versus public health. Medicine is the presence of disease. Public health is the absence of disease. When we as public health people are successful, nothing happens. That's a real problem. I'll tell you why it's a problem. It's what I call obliviousness to absence. So it's hard to get people excited about something that's not there. If you're having a heart attack, you will do anything to stop that heart attack. You will let some cardiovascular surgeon who you've never met in your life crack your chest, right? On the other hand, you may very well not have been taking your antihypertensives and your statins and eating well and exercising and doing all those things that public health people told you to do for years and years and years and years, right? That's obliviousness to absence. That's a great reversal. Okay, reorganization and rearrangement. We all have what's called functional fixedness. We think there's a particular use for a particular thing. Quick experiment. If I was to give you a candle, a book of matches, and a box of thumbtacks and say, okay, what I want you to do is attach the candle to the wall, unless you had heard this before, many of you would be hard-pressed to figure out how to do that. I'll tell you how to do it. What you do is you take the box of thumbtacks, you take the thumbtacks out of the box, you use the box as a candle holder, put the thumbtack through the back of the box, use that as a candle holder, and you've just attached the candle to the wall. Use the box of matches to light it, the book of matches to light it. Okay, but the thing that makes that hard is that you had to take the tacks out of the box. which doesn't sound like a big deal. But if I gave the experiment to you in a different way and I said a candle, a book of matches, a bunch of thumbtacks, and a box, you'd instantly get it. If I give it to you this way, the vast majority of people can't figure it out. This is a fantastic example of reorganization and rearrangement. This is a neonatal incubator built for the developing world out of used car parts. I'm not going to go into all of it. But Edison is the perfect example of the great reorganizer and rearranger. I'm going to tell you that he never invented, out of his 1,000+ patents, not never, but almost never invented anything that was truly novel. What he did brilliantly is he took other people's inventions and put them together in very unexpected ways. So finally, the power of groups. Now, we all kind of accept that these days, but we think of groups as being smart. We don't necessarily think of it as being more creative than an individual, but it actually turns out that in some circumstances, especially over the internet, they are. And this is a great example. Some years ago, DARPA, which is the DoD agency that funds a lot of creative research, amazing agency, put out this challenge. They said, we'll pay $40,000 to the first person or individual that can find 10 fixed weather balloons, big red weather balloons, scattered somewhere in the United States, all right? How long do you think it took to find 10 weather balloons somewhere, anywhere in the continental, outside in the continental United States? How long do you think it took? 1 day. I'm sorry, 5 days? 5 minutes. 5 minutes. What do you think they did? It took 8 hours. It took 8 hours. And you know who did it, right? It was a group of MIT students. Of course it was. So this was in the early days of the internet. It was before social networking and all that kind of thing, but we did have the internet. And they instantly put up a website. Here's the problem, though. How did they get people to come to the website fast enough, right? I mean, there are a gazillion websites out there. They needed to do this as fast as possible. It was only going to take 8 hours, right? So they had to find a bunch of balloon detectives as fast as possible. How did they do it? They used a pyramid scheme, literally. So here's what they did. They said, look, if you go out and you find a balloon, you get $1,000. Well, that's great, but that still isn't going to bring people in fast enough. It's not going to get people to recognize the website fast enough. So then they said, if you bring someone to the website that finds a balloon, they get $1,000. You get $500 just for finding the person who found the balloon. And if you're 2 steps removed, you get $250. And if you're 3 steps removed, you get $125. So now, not only did they have all these balloon detectives, but they had people detectives finding the balloon detectives, right? Is that brilliant? That was pretty darn creative. Okay, so harmonizing. This is basically the scientific process: hypotheses, expectations, observations, inferences, and you can just imagine that these tools and frame shifting can get embedded in every one of these different steps. Last thing is, I'm just going to share with you a piece of work that my students did. So when I teach this, I always assign a final project. Even in the massively online course, there's kind of a final project. You have to find a problem. You have to come up with an innovative solution using the tools. So their problem was basically your last will and testament, right? So what we call advanced directives. These are the decisions that you make about what you want to happen to you at your end of life from a medical perspective. So the problem was that the frame of death is, well, it's pretty fixed. It's pretty scary and sober and mysterious. Coming up on Halloween, this is a good story to tell. So anyhow, we approach it with awe and fear, right? That is Halloween. And very few people have advanced directives. It's a huge problem in the United States. It has massive costs because we do all sorts of things to people that they didn't want if they had just told us what they wanted, but they don't. So my students thought because they couldn't figure out how to break this frame. That is what death is. It's nothing, that is what it is. Finally, they had this epiphany. And the epiphany was, what Ben Franklin once said. This aphorism was, you might remember, nothing is sure but death and, thank you, taxes. This is what they came up with. This is called the U.S. Individual Advance Directive Claim Form. And what happens is it looks exactly like a tax form. You fill it out exactly like a tax form. It has little checkoff boxes. But the checkoff boxes say things like, I do or do not want to be intubated under the following circumstances, add your own. I do or do not want to be tube fed. I want to have a surrogate. I want, on and on. So it's got all these little things. And the way that it would work is each year, when you electronically filed your taxes, you would have the option to also electronically file this form. You'd get a little tax rebate for doing it. It would get hooked to your medical record, and voila, everyone would know what your advance directives are. They've actually published this. We're waiting for the IRS to pick it up. It's beautiful. So anyway, the way it works is you define the problem, you gather the information in a very frame-free way, separate these raw inputs from the frames, you generate lots and lots of original ideas. I only shared with you a very small number of the tools because I had so little time, but tons of ideas. Ultimately, you want hundreds of them, and then you're going to converge on one or two that you can actually test, and that you develop into hypothesis and a plan, and you can test that scientifically. So thank you for listening. Those are some of the books, and enjoy. Thanks.
First, I'd like to thank the AAAS and the Dana Foundation for organizing this wonderful event, and I want to thank Mark Frankel for inviting me and Bethany Spencer for her superb organizational work. Okay. Let's see. Okay. I'm going to talk about the cognitive neuroscience of creative insight. But first, we're going to start with a little astronomy lesson. Galaxies come in all shapes and sizes. There's the traditional spiral galaxy you see in the upper left. There are elliptical galaxies. There are various structures and forms for galaxies. And it may surprise you to know that as recently as 1950, nobody knew what the shape it was or is of our galaxy, the Milky Way. The problem is we can't leave the galaxy, turn around and look at it and see what the shape is. So it's a complicated problem. This is the great astronomer William Wilson Morgan, who was working one day in 1950. This problem interested him, but this wasn't what he was working on at the time. He was computing the distances of what are called OB associations, which, there we go. They're young, hot, bright stars. They cluster together. They're star nurseries, essentially, where stars are born. He knew, and we still know now, that OB associations in spiral galaxies, they cluster in the spiral arms, not in the center or other parts, but in the spiral arms. In other kinds of galaxies, they exist in other parts of the galaxies. So one day, or one night, he was working at the Yerkes Observatory, and he was computing the distances from Earth of a number of these OB associations, and he knew them well. He quit work for the evening, and he started walking home. And as he walked home, he looked up at the sky, and he saw some of the OB associations whose distances he had been computing. He knew their distances. And then in that moment, he had a spontaneous insight, an aha moment. He later described it as a flash inspiration, a creative intuitional burst. In that moment, his knowledge of the distances of these OB associations merged with the flat two-dimensional image you see when you look up at the night sky. And he could see the stars in depth. And when he saw that, he realized that these OB associations in 3 dimensions exist in a long strand in 3 dimensions, in depth. And as that happened, he realized that this strand was a spiral arm of the Milky Way galaxy. He, in that moment, directly perceived the structure of the Milky Way galaxy. He was the first to do that in a startling, sudden insight. He later collected data to verify his perception, and he presented these data at a conference of his colleagues to thunderous applause. And this is a great aha moment. I would say it's one of it ranks up there with Newton and the apple and other great aha moments, although it's not as well known as some of these more famous examples. So he had this epiphany, this sudden insight, this aha moment, eureka moment, whatever you want to call it, at an instant in time. These different pieces of information snapped together, and he was illumined. He understood the structure of the Milky Way galaxy. Well, for a number of years, my colleagues and I have been looking at what happens in the brain when a person has an aha moment. Now, we can't chase around eminent scientists and artists and anticipate when they'll have aha moments and then shove them in a brain scanner or wire them up with electrodes. Can't do that. And in fact, we wouldn't really want to, because once they've reached that level of eminence, their brains must be changed not only by the creativity, but they must be changed by the success they've had, the fame they've had, perhaps even riches and all that. So we don't want to be chasing around people like Steven Spielberg or whatever, even if we could. We want to use try to get better control over the situation and the people. So we've been using a series of puzzles to study what happens in your brain when you have an aha moment. And we've used various kinds of puzzles and problems. Some are visual, some are verbal. One of the main ones we've been using, it's called compound remote associates problems. These are one type of problem from a test of creativity that Sanford Mednick developed back in the early 1960s, but with some refinements. And we have, about 200 of these things. And each one consists of 3 words. And you have to think of what is the 4th word that makes a compound or familiar phrase with each of the 3 words. And these problems are pretty difficult. I mean, our undergraduate subjects usually don't solve more than about half of them. In this case, the solution is dog. Hot dog, dog food, dog catcher. Now, one of the things that's interesting about these problems is that it can be solved in 2 different ways. One way is you look at it and bang, the solution just pops into your head. That's a sudden insight. So you can solve it with an aha moment, or you can solve it in a more deliberate analytical fashion. You might try hypothesis testing. So you look at dog, you say, what goes with dog? Well, what goes with hot? Cold goes with hot. Does cold go with food? Sure. Does cold go with catcher? Nah. Try something else. What else goes with hot? Until you finally hit on dog. You can do that systematic, deliberate hypothesis testing. Okay. And actually, let me go back. In our neuroimaging experiments, we use these problems, and we're able to look separately at the problems that people solve with a flash of insight and the ones that they solve in an analytical fashion. And this corresponds to a well-known distinction within cognitive psychology. If you've read Daniel Kahneman's book, Thinking Fast and Slow, he called it System 1 and System 2. The more modern terminology is Type 1 and Type 2 because they're not really distinct systems. And Type 1 processes are unconscious, associative, effortless, spontaneous. This is what provides insights. Cognitive psychologists call them insights, this outside-the-box thinking, the aha moment. Analytic thought is conscious, logical, effortful, and strategic. That's the so-called inside-the-box thinking. That's ideal for when you sort of already know how to solve the problem, or at least have a general idea, and you're using known methods to do that in a conscious, deliberate way. All right, so you might ask, how do we know when subjects, our participants, are actually solving a problem with a flash of insight or solving it in an analytic fashion? And there are several lines of evidence that allow us to make that conclusion, but I'll just describe one. Okay, here we go. This is from one of our behavioral studies. We've replicated this in a number of studies as well. You see on the horizontal axis, the percentage of errors that are errors of commission. So there are 2 ways you can make an error. You can make an error by offering a solution that's wrong. The other way you can make an error is by not offering a solution at all. We have a deadline, they time out, they have nothing to say. Right? So some subjects, each dot is one subject in the experiment. Some subjects make more mistakes. They give wrong answers. And others make more timeouts. They just draw a blank. On the vertical axis, we have percentage of solutions that are insights. So of all the correct solutions you give, what percentage of them are identified by the subject as being an insight, and what percentage are identified by the subject as being analytic? So we just asked them, was that an insight or was that a deliberate, methodical solution? And as you can see, some subjects are way at the top, and there we call them insightfuls. They solve a lot of their solutions are due to these self-labeled aha moments. And at the bottom we have people who are the analysts. Most of their solutions are self-labeled as due to deliberate hypothesis testing, logical thought. And what you can see here is that the people who are the analysts, they tend to make more mistakes, more errors of commission. You can see them in the lower right-hand corner. And the people who are the insightfuls, their errors are timeouts. That's the upper left-hand corner. They tend to draw a blank. And this makes perfect sense. You're working on a problem. You know there's a deadline. You're in an insight mode of thought. You're drawing a blank. The deadline's approaching. You want to say something. You don't want to just time out, but you haven't had your aha moment yet. You haven't had your epiphany. You draw a blank, you time out. That's an error of omission. But if you're in an analytic mode of thought, you're doing deliberate hypothesis testing. Hot, what goes with hot? Cold goes with hot, etc. The deadline's approaching, you don't want to time out. So whatever is in your head at the moment, whatever that hypothesis is, you're testing at the moment, you blurt it out, and it might be right, it might be wrong. If it's wrong, it's an error. It's an error of commission. So you can see here that people are able to very accurately identify when they're making an insight, when they had an insight, and when they solved a problem with deliberate analytical thought. Okay, so we used both high-density EEG, electroencephalogram, in the upper left, and fMRI, functional magnetic resonance imaging. We use these two techniques because EEG has superb temporal resolution. It can tell you within a few milliseconds when something's happening in the brain, but it is less precise about where something's happening in the brain. fMRI has exquisite spatial resolution. It can tell you with great precision where something's happening in the brain, but it's less precise about when it's happening in the brain. When we use these two techniques in separate but parallel studies, we're able to localize in both space and time the aha moment, the moment of insight. And the reason we want to be able to do that is that if we use just fMRI alone, we would see all these brain areas lighting up when you have an insight, but you wouldn't know whether they're coming before the insight or after the actual insight. So we need the EEG for that temporal precision, and we need the fMRI for the anatomical precision. And this is the basic paradigm. Time goes from left to right. You see a problem on the screen, in this case, the hot catcher food problem. The instant you have a solution, you press a button, that's the yellow R, and we tell the subjects, when you have the solution, don't keep thinking about it, just hit that button right away. Then they get a prompt, it says solution there, to verbalize the solution, and then another prompt to press a button to indicate whether that solution popped into their minds as a sudden insight, or whether it came from analytical thought, this deliberate methodical thought, or we give them a third button if they're not sure. But almost nobody ever presses the third button because people have a very good intuitive sense. A few people, maybe on the order of 1 or 2% of the solutions are unsure. And this is what we found. Again, on the horizontal axis, time goes from left to right. You could see the R is the moment where they press the button to indicate that they have the solution. The vertical axis is gamma waves, gamma power. It's a measure of EEG activity, high frequency brain activity. And you could see there are separate lines there, one for solutions by insight, one by solutions that are analytic. And about 300 milliseconds before they press the button, there's a burst of this high frequency EEG activity. Now that 300 milliseconds, once the solution pops into your mind, it takes you about 300 milliseconds to actually press the button. So that 300 milliseconds before the R, that is when the solution popped into awareness as a sudden insight. And to show where this occurs, this is an EEG map. It's the right side of the head. Each of the red dots is the location of an electrode. And this, we're plotting here the difference. It's the insight EEG activity minus the analytic EEG activity. And you can see there's a burst of activity just above the right ear. With fMRI, we can see this is the right anterior superior temporal gyrus, the right temporal lobe. Actually, this was mocked in an episode of 30 Rock, where Alec Baldwin explained that his right anterior superior temporal gyrus just was lighting up and he was having a cognitive inspiration and all that. So this kind of reverberated through the pop culture. If we had more time, I'd play you the clip. Anyway, so we have that right anterior superior temporal gyrus, that right temporal lobe burst of activity is the insight. What I don't have time to explain much of is that there are a series of brain states and brain processes that lead up to that burst of activity in the right temporal lobe. You're not aware of them, but there are these processes. If you're interested to know more about these different intervening processes, you can check out our new book that I co-authored with Mark Beeman, The Eureka Factor. It talks more about this and the different factors that can selectively influence these brain states. But what I am going to talk about now is the first of these, resting state brain activity. Okay? Resting state brain activity is what occurs when a person sits there quietly with no task to perform, no particular anticipation of what's going to happen next. They just let the thoughts flow. Okay. And so what we did in this study is we recorded resting state EEG from subjects, each one in 4 sessions, and then we gave them a bunch of anagrams to solve. So they had to unscramble letters to find a word. And for each solution, they identified this one was an insight or this one was an analytic, methodical solution, etc. We classified the subjects into the ones who were the insightfuls, the ones who got most of the solutions from sudden insights, and the ones who were the so-called analysts, the ones who figured out these anagrams in a deliberate, methodical way. And this is what we found here. This is, again, high-frequency EEG activity, gamma waves. And this is a top view of the head. The nose is at the top of the figure. The back of the head's at the bottom of the figure. The right side of the head's on the right, etc. The so-called analysts, they have more activity in the left frontal area of the brain, and the so-called insightfuls have more activity in the right posterior part of the brain, the right parietal lobe. So insightfuls have reduced frontal lobe activity, and analysts have reduced posterior brain activity. And this roughly corresponds, not even so roughly, kind of exactly, to the type 1 and type 2 processes. So we have the insightfuls. They use unconscious, associative, effortless, spontaneous thought. So insights just pop into awareness. Whereas the analysts are using conscious, logical, effortful, strategic thought. So your cognitive problem-solving style, how you attack the problem, is at least partly determined or influenced by your prior resting state brain activity. And this prior resting state brain activity is partially trait-like because, you know, we measured their EEG activity for 4 sessions over 4 different days. Each session was about a week apart from each other. So this is fairly stable. There are factors that can perturb this resting state brain activity, but it's fairly stable. Okay, so that brings us to the question, and this is a really hot, controversial area in creativity research right now. What are the relative contributions of type 1 and type 2 processes to creative production? There's just a lot of arguing going on among cognitive psychologists and cognitive neuroscientists who are studying creativity right now about, you know, they have different definitions. Some argue that the type 1 conscious deliberate processes, that's really what creativity is, and others argue that no, it's the type 1 processing that's really the creativity, the unconscious. I'm more in the type 1 camp myself, as you'll see why. So, a final study. We had a hypothesis that the role of expertise, how expert you are in a particular domain will determine the extent to which you use type 1 and type 2 processes. The idea is that when you're still a relative novice and you're thinking about whatever your area is, whether it's physics, whether it's music, whether it's sculpture, whatever it is, you're thinking in a very deliberate, methodical way. Should I try this? What if I do it this way? What if I change it and do it that way? That's type 2, if you're a novice. If you're an expert, you don't do all that. You don't have to think things through in that exquisite detail. What it is, you turn on the faucet and ideas come out. Okay? Now, that's not to say that real experts don't think analytically also. Often what they do is they have a great insight, and then they turn on their analytical thinking to refine it, critique it, adapt it, implement it, etc. But it's the insights, it's the type 1 processes that produce the ideas. So, in this study, which has just been submitted for publication, we used jazz pianists of different levels of experience. Now, we couldn't get the most experienced, expert master pianists. We got ones that range. They all have played public performances, all have played public gigs, but they range sort of from, not novices, but not very experienced pianists to sort of moderate levels of experience. And we gave them, they had to improvise to a specified chord sequence and rhythm accompaniment. And here's the thing. There's an interesting finding in the creativity literature that goes back many years. Strangely, if you just tell people, now be more creative, they often are. Just the instruction, just that admonition, be more creative. Often they can do it. And it doesn't always happen, but it happens in a lot of different domains, and it happens fairly reliably. Okay? So we used that, we had the pianists improvise both before and after they got that admonition to be creative. And what that admonition does is it kicks in type 2 processing. Once you give a person a goal, be more creative, okay, that kicks in these executive processes. It kicks in strategies, mental strategies they may have or they want to try to be more creative. So we're ramping up type 2 processing, this conscious, deliberate processing. And we recorded all these performances, and then we had jazz experts rate them for their quality and their creativity. And this is what we found. The horizontal axis is the logarithm of the number of jazz gigs that they played. So it's a measure of their experience, their expertise. The vertical axis is the ratings of their performance. And if you could see at the low number of jazz gigs, these are on the left, those are the less experienced pianists. The neutral condition, their quality is fairly low. But then when you tell them be more creative, you can see they improve. And that's a significant improvement. If you look at the far right side, it looks like there's a bit of a crossover. Now, that difference on the right side is not statistically significant, but it's certainly suggestive. What we can say is when you look at the people who are sort of moderate levels of expertise and you tell them, be more creative, it doesn't help them. It may hurt them a little, not significantly, but it's not helping them. And we hypothesize that if we had some really expert pianists, some of the really best ones, that crossover would be more complete. As it is, with the more experienced ones we have, some of them, when we told them, now be creative, they looked at us like, what do you mean? I'm always creative. I just turn it on. I don't have to do anything special. That's what happens, right? So you can see then, with the less experienced pianists, you do something to kick in this type 2 processing, this conscious, deliberate processing, and it helps them. They use strategies. They spontaneously bring strategies forward to try to produce something that's more creative. It doesn't work, but you can see the level of experience. There's a big increase. The more experienced pianists they do produce much better products, more creative products. But the admonition to be creative does not help. Okay, so it's what Charlie Parker, the jazz great, says: you've got to learn your instrument, then you practice, 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 and then when you finally get up there on the bandstand, forget all that and just wail. Thank you, Charlie. Okay, now, all right, enough Charlie. Now, so what are the takeaways from this? First of all, creative insight is largely spontaneous. It's not a product of conscious strategies. If you look at the real masters, the real experts in any domain, they don't sit there and use conscious strategies. What happens is often ideas just come to them. It could be in the shower. It's often while taking a walk. And what's really interesting about creative insight is that often it produces an idea which is a solution to a problem no one even knew they had. In other words, you could just have a great idea. It's not necessarily solving a problem you were thinking about, but ideas just happen. They're spontaneous. This type 1 unconscious processing, these things just bubble up sometimes. Deliberate strategies, these type 2 processes, can be used to solve problems. They can simulate innovation, but they're not creativity in the sense of this unconscious type 1 process. These deliberate strategies, they work when you know what to do already. So for example, you could have a bunch of conscious strategies you could use, but first of all, you have to recognize you have a problem to solve or need to produce something, and then you need to know which tool to use. And that's not a straightforward matter. Often that even takes a creative insight in itself to know what to select. But these strategies are mainly useful for novices or students who are in the beginning of learning a particular domain. Okay? And there are trait-like individual differences in the pattern of resting state brain activity that are conducive to insight or analysis. Now we know, and I don't have time to talk about, that there are factors that can influence that. Things like mood, deployment of attention, and other things that can nudge you in one way or the other towards insightful or analytic thinking. The way we like to think about it is that this cognitive style, whether analytic or creative, it's sort of like your weight, in the sense that people have a genetically determined set point for their weight. Some people are naturally genetically more heavy, others are genetically thinner. But there are things you can do to slide around. If you're naturally heavy, but you don't eat too much, you eat healthy food, you exercise a lot and sleep a lot, your set point will come down and you'll get slimmer. If you're naturally thin, but you eat a lot of bad food, don't exercise and don't sleep, your set point will go up. So similarly, we believe that there is, and this is something that we need to get some good data on, that this insight analytic or creative analytic dimension is partially genetically determined, but there are environmental influences that can slide you temporarily one way or the other on this scale. But in the absence of those influences, you'll kind of snap back to whatever your set point is. Okay. So there are factors that can nudge that brain state in one direction or the other. Okay. And I'd like to thank the National Science Foundation for funding much of the research that I described. And I'd like to thank you.
Well, we are running a bit over, but given the fact that we've had such an interesting set of presentations, I'd like to call our other speakers up if they'd come up on the stage and put the lapel mics on, and we'll have some Q&A from those of you who have been sitting patiently and want to ask them anything that comes to mind about the presentations you heard or other things you might think about the notions of creativity and genius. They'll get their mics on. There are microphones on the side here, on the both aisles. And I ask you to go to those microphones now, get a place before too long, so that we'll just run maybe another 5 to 7 minutes before we break for our reception.
Logan Melendez, Department of Commerce. So my question is, with mathematical genius, is there any distinction in the processes that go on that enable that? Is it basically interchangeable with, say, artistic genius? And is there any relationship? I mean, we hear that some of that creativeness or approaches savant-type personality. What's the connection between those?
Who are you asking?
I think I would ask all three of you.
Yeah. Who wants to take a crack at that? At that first.
I'll take a first stab. I don't have a lot to say about that. I think there is reason to believe that there are some core processes that are common to different domains of creativity. But, you know, I just don't think the research has been done yet. I mean, that's one of the key questions is what does mathematical creativity have in common with musical creativity, with other kinds of creativity? And in terms of what these core processes are, we have some good ideas about what they are, but you know, in terms of reliance on left hemisphere versus right hemisphere, ability to activate or deactivate frontal lobes, things like that, but we really just don't know that much.
Any of the other speakers want to respond?
Just a random thought. I've been thinking a lot about creativity in 19th century physicists, and each of these people I've actually lived with for a couple months. And one of my favorites is James Clerk Maxwell, who's the prototype of a gifted mathematician. And he had, first of all, an amazing capacity to think three-dimensionally. Secondly, he had, like many mathematical geniuses, an ability to see the solution to the problem without knowing how he got there, which is often a problem with creative mathematicians. They get in trouble in school because they see the answers, but they don't know, you know, they can't show their work and they get punished for it, which is a terrible outcome. The other thing about him was that he, and this is, I'm using him as a prototype, but it could be Richard Feynman, it could be a whole host of other people. He thought geometrically in 3 dimensions all the time and had just this amazing ability to do 3-dimensional geometric thinking. And there's a cute story. He was a student at Cambridge. There's an exam, the Tripos exam, which makes you or breaks you, or at least did, especially in the 19th century. If you score well on it, you're a senior wrangler, second wrangler, and those were published publicly. And if you were senior, second, your career was made for life. And they were trained by wrangler makers, other mathematicians. And so he was getting trained by a guy named Hopkins, who was the great wrangler maker of his era. And Hopkins was just scribbling all over the blackboard with a solution to a problem, and Maxwell jumps up and says, well, wouldn't it be easier if you just did it this way? And he draws a little geometric diagram that solves the problem, and then he wrote out the algebra. He solved the problem in like 3 lines. Where does that come from? I think in his case, in many cases, it's just innate genius.
I'll just make one very quick comment so that we can get on to another question. But the reason why I want to make this comment is I think it kind of ties up these kind of 2 concepts of insight versus, you know, kind of a tool-based or toolbox-based approach to thinking about the cognition of genius. So Einstein, very much like Maxwell, did exactly the same things that Nancy was just talking about. He was very much a geometric thinker. He had these, what would be considered insights. You know, he suddenly found solutions to these problems it was very unclear kind of how he got there. I discuss him at length in the book Genius Unmasked. The reality is he was using all these tools, it's just that he didn't know he was using them. And what happens with real experts is, what happens with novices is, they have to do this very purposefully and very systematically, and they have to go through every tool and think it through. When you've used the tools over and over and over and over and over again and have gotten just so incredibly comfortable with them in your expertise, you're completely unaware that you're using the tools, right? So I believe that's what we call insight.
Okay, well, let's go on over there, please.
So the first two speakers were talking about genius, okay, Leonardo, Michelangelo, Nobel Prize winners, and so forth. John, I think, was talking more about sort of more
Could you speak into
everyday
the mic a
level.
little more?
Okay. John, I think, was talking about some more everyday experience of the differences between experts and novices. I wonder how you see the relationship between the geniuses and the experts, and the everyday property of all human beings, and the novelty and creativity that every single member of our species has, whereby we are expressing new thoughts, having new thoughts, expressing them on a minute-by-minute basis. It might be quite trivial, right? I'm going to get the bus that comes at 3:38 from across the road. It may never have been said by anybody before. We have no difficulty saying it. We have no difficulty understanding it. And it's part of it's a fundamental property of human beings. And I'm wondering how you see any relationship, if any, between that kind of creativity and the creativity of geniuses.
Well, I'll start on this one since I was last on the last one. I just want to clarify, I was not talking about just geniuses. I was very much talking about something that anyone can be taught to do to enhance their creativity. But so they're directly related to each other in my mind. Geniuses were just extraordinarily gifted at using these tools. But when you dissect their thinking process, which is exactly what I did in Genius Unmasked, I literally go through, they used this tool when they went from step A to step B, they did this thing when they, it dissects. I think it's, many reviewers have read it and find it somewhat convincing that really, they were using this multitude of things. But and again, you can teach people. I do teach people. I have this, massively online course that teaches people to use these tools. But I do want to just go beyond your question just for one quick second to say two things. One is finding the right question is incredibly important, and geniuses were geniuses at doing that. Einstein once said something to the effect of, if the end of the world was coming and somebody asked me to find the solution to it and they only gave me 20 minutes, I would spend the first 19 minutes trying to figure out what's the right question. But the other thing to say is that, and I want to kind of get at kind of the current generation, and one of the things that worries me as I am a teacher, I teach graduate students, but one of the things that worries me enormously is that in addition to finding the right question, in order to really be creative, like John said, you have to give people the space to be creative. Nancy said it too, but you have to really engage people in their curiosity. And one of the things that worries me a lot is the first thing that I ask my students when I walk into a classroom is, what are you curious about? And always the answer is a blank stare from all of them. They're dumbfounded by that question. So the next thing that happens is they start telling me about their thesis or their dissertation project, and I say, I really don't want to hear about that. I want to know something that you are just curious about, having nothing to do with science. How about that, right? And after they've been I've sat there for about another 5 very, very, very uncomfortable minutes. Finally, some bold person will say something fairly crazy, and then they'll all start jumping in with all this stuff that's just wacko, and it's fantastic. But the fact of the matter is that in the educational process today, we do not engage people in their creativity, and that's a real problem.
Anybody else on the stage want to chime in?
I'd like to say there are several things that are similar and different. For one thing, when a genius has a great idea, there is a difference of scale. Often these geniuses are experts. They have a vast storehouse of detailed expert information about that topic. So when they have an idea, sometimes it can be a very complicated idea because they have the information or the knowledge to do it. However, the processes by which they come up with these solutions may be very similar to those when people solve little problems. And in fact, if you think about it, some of the great ideas of history are great because they've been so valued by society. Now, if we lived in a society in which people valued equally solutions to little puzzles, then some of those people would be considered great geniuses. Or for instance, compare, for example, Russia and the United States. In Russia, people who are chess champions are gods. I mean, they are huge celebrities. You know, 40 years ago when Bobby Fischer was playing, that in the United States, maybe that was true to a little extent. But nowadays, I think most people, Americans off the street, can't name a single professional chess player, chess master. So some of it has to do with what's valued by society, what's practical, what's useful, what's considered beautiful. But the processes by which ideas are generated, there's no reason to think that those are really qualitatively different in everyday creativity. I mean, my auto mechanic, he's a genius, the way he can figure out, you know, things that stump other mechanics. But, you know, auto mechanic, that ability is not valued as much as Feynman's ability to solve problems in physics.
Okay, how about over here? Why don't we just make these the last two questions, and then we'll go ahead.
Ida Charles, Society for Developmental Biology, and this question is for Dr. Andreessen. In your imaging research, have you seen any difference in localization or activity in the brain between people who are considered genius and the common people? And also throughout development, have you seen any difference in the physiology and the activity of the brains in your imaging research?
It's for me.
That's the question for you.
So what was the question? I couldn't hear.
The question is there a difference in brain imaging between geniuses and people who are not geniuses?
Okay. First of all, I don't like the word genius. I would call people who are often called geniuses highly creative people. We are doing a study right now of highly creative people. You didn't like Steven Spielberg, but I have George Lucas.
Oh, I like them. I love them, but I'm not sure how much I would learn from studying their brains.
You know, I learned a great deal from George Lucas. What I do in this current study is interview them for 4, 5, 6 hours and hear all about how they get their ideas and, you know, their early life and all of that stuff. And it's just an absolute gold mine of information about the nature of creativity, what nurtures it and what diminishes it, the nature of the creative process, and so on. So the question was, can we learn something about the brain in highly creative people? And in this current study I'm doing, it's a group of people like George Lucas who are highly creative, Nobel Prize winners, and so on. And it's midstream, but so far we're finding that people who are highly creative activate basically the association cortices. The association cortex are the regions of the brain where we make connections. And one of my theories about the nature of creativity is that it's an enhanced ability to see connections, to see relationships. And indeed, these highly creative people are activating their association cortices more intensely than the less creative people, because we have a comparison group of people who are matched on gender, age, education, but are not known to be highly creative and aren't once we interview them. So yeah, we're learning a little bit. We're learning a little bit about the brain regions that are active in creativity or more active in highly creative people. And that's turning out to be, to me, not surprisingly, association regions in the brain.
Okay, last question.
Yeah, name is Rick Lempert, Emeritus Professor, University of Michigan. Following up on David Lightfoot, who preceded me, his question. I heard, John, you say, I think that geniuses are to a large extent socially constructed. I agree with that. Anecdote, when I was 5 years old, I invented the over-easy egg. My father used to fry me eggs sunny side up all the time, and one day I said, turn it over. And he did. It was delicious, and I was so proud of myself for this invention. It was only later when I found out at the local diner that someone had preceded me. And I expect everybody in this room could come up with a similar anecdote of something which, with no background and a flash of genius, if you will, they invented, only to find out it wasn't original. And I guess my question I'm using this to take off from, is there any research or any planned research that might try to evaluate among a range of ordinary people what one might call the density of creative thinking, the degree to which different people in their day-to-day lives, in fact, from where they start, come up with ideas that are original and creative to them? We know the geniuses because they take problems that are out there and they're equipped by their prior knowledge almost always to come up with the insightful solution. But what about the rest of us? What kind of research is going on, not just on the very interesting neurological research and how it works, but on what I would call the range of creativity in normal populations?
Yes, Teresa Amabile at the Harvard Business School did for many years a study where she went into various corporations and had the workers keep diaries on their work and their moods, their emotions, everything they experience. And she looked at when and what kinds of creative ideas people have, when they have them, the sequencing, what was going on in their lives at the time. That's one very good source. Right now, Jonathan Schooler at the University of California, Santa Barbara is in the middle of a study where he's not looking at everyday people, but he's not looking at necessarily at people who are at the level of Leonardo or people like that. He's looking at scientists and people in other disciplines as well. And I believe he's actually buzzing them on their smartphones and asking them at any given moment, what are you doing now? What are you doing now? What are you doing now? And getting records on also when it's pretty disruptive, but also when they get ideas, what the circumstances were as well. So yes, there has been work like that. Not enough. We need to have a lot more work like that done. It's very complicated and very expensive to do, which is part of the problem.
Would any of the other speakers like to react to that question as well? No? Okay. Food and beverage awaits us in the outside the auditorium.